In my last video, I featured a master-slave setup using the Pico 2W as the master and the Pico original as the slave. In the master, I set up a web server to serve an interactive web page. Now, the web page itself was rather complex. It had an index.html, a CSS styles CSS file, and an app.js file, JavaScript, and was pretty proud of it. It looked great, and it did work somewhat. The somewhat part was that it was just too much. It was just loading the Pico 2W, and to my heartbreak, I rethought the whole idea of serving a full-scale website on the Pico 2W. It just can't handle it. It's too much. A better solution, in fact, a wonderful solution, is just to have the Pico 2W serve a JSON file, a JSON string, and that's it. And it can send, so your web page will actually be not on the Pico, but on a server on your network. And here I've got an old crappy HP knockoff that's doing a pretty good job of serving the MySQL and PHP and Apache. And that's the address here, 113. And I have a folder in XAMPP htdocs called Pico Read. And I developed, you can develop, obviously when you're putting it on a standalone web server, you can make a much more robust web page, website, everything. And that's what I've done here. So it gets information in the form of a JSON string from the Pico 2W. And that information is temperature, and 1 byte is for LED state, LED state, and the numeric values are all in binary. So, oh, I see I have to change the labels here. Ignore the man behind the curtain. He's illiterate. Green is 1, yellow is 2, red is 4, blue is 8, and I have blue here on my actual setup. On my breadboard, I have 2 devices. The Pico original is the slave, and that's actually controlling the LEDs and reading the thermistor and sending that value to the ADC pin. So the Pico slave, the Pico is controlling the LEDs and the temperature, and the Pico 2W is like the middle manager. It's taking commands from this web page. So if I push a button here, see the LED state's going to change. Well, first you can see it's sending a JSON string back to the Pico W. This web page on the web server on my network, which is a computer sitting on a desk, is so I just clicked the red, which is 4, 1, 2, 4, 8, 4, and it's sending a 4, and now it's actually toggling these, so there's a couple things that are not quite ready with this. This is a preview, okay? I have to do something to indicate that this is on or off, and that's pretty easy to do. Now I clicked red. An LED state of 7, well, if you know your base 2, you know that 4 plus 2 plus 1 is 7. So on the board, we're actually going to see these 3 lights lit up. And if I click the 4th, I have an optocoupler with a remote 5-volt electrically isolated circuit controlling the output of the optocoupler and the LED. And now all these LEDs are on. So it's sending a byte back to the Pico 2W, the master. And the byte with 8 bits. I use each of those bits as a switch. And right now the only switches in that byte are the first 4 bits. The 1's place, 2's place, 4's place, 8's place. And then there are 4 more unused bits over here we can use for other stuff. So you can see the LED state. The state is being sent back. It's being sent to this web page from the Pico 2W. And the value is 15. That means 8 plus 4 is 12. Plus 2 is 14. Plus 1 is 15. So all of these LEDs will be on. In the next video, I'm going to show you the whole thing, the boards and everything. Meanwhile, I haven't talked about this, but it's taking the temperature. The Pico is taking the temperature, sending that temp value, sending that raw value to the Pico 2W and sending it to the website where a PHP file parses the value, the raw ADC value, and we extract the temperature value out of that, convert it to a Fahrenheit reading, and then we log that reading. Yeah, so we log that reading to a MySQL server, which also exists on the web server machine. That works very well. It's slow as crap, but for headless stuff and for serving web pages in MySQL, it works pretty good. Now, you can see that we're dynamically, every minute we're reading the last 20, is it? I guess 30, 40 temperature readings, and we're inserting the new one, and we have it so that it's going backwards. So this is the most recent reading, and then all of these are MySQL records in the log table. So we're logging the temperature to a table, and we're reading from that table. So we're reading the temperature and the LED state from the Pico, and then this web page parses that value delivered in the JSON string, and we separate it into the lower byte is the color, the state of the LED, and the upper 2 bytes are the value from the ADC, and we take that and we convert it to a temperature, which you can see is changing here dynamically without refreshing the page. So there's some JavaScript involved and some other stuff, and we write to and read from the MySQL database. Oh, okay, so originally this was a struggle writing in a program in C to connect to the MySQL database. It was unimaginably complicated for me. There were all kinds of things I had to install using Bash and Ubuntu, and oh my lord, it can go on, and I am not going to write a tutorial on that. It was just ridiculous. But eventually I got it working. Then what happened? I learned that you cannot put this program on the Pico, which is an entirely different architecture from Windows, a 64-bit Windows machine, which is what I'm programming on in Visual Studio Code. Very difficult. So here I am. I finally have the C program MySQL connector solved. I'm reading and inserting into the MySQL database just fine. But then I learned I can't put this program I can't piggyback it onto another program. It won't work on the Pico. Yeah, also it was a very ugly mess because I had to download all kinds of DLL files from the MySQL folder. So it was just not very elegant code, but it works. I'm not using it at all now. My MySQL connectors are all done through PHP. So this is all a PHP file. And part of it is HTML, and then the HTML calls JavaScript, and the HTML references the CSS file. So this is just a kind of like a traditional interactive web page using PHP. I'm not using the C program, but I'm going to think about it. I'm going to think about how I can incorporate a C program to handle this stuff, or maybe just the insert. I don't know what I'm going to do. Right now, this works just fine, and it is the correct solution. So what you want is, here's the API. See, so this is addressing the Pico. This is not. You can see that this is 192.168.1.13. This is the laptop web server. But this is 183. This is 113. And this is 183. And 183 actually has an API endpoint. And here the status, you can see we got raw. These numbers are screwed up. The temperature is mostly correct. The lead state is correct. The timestamp, I don't actually use that. I auto insert the date time in the MySQL table. But here's the timestamp. This looks like raw and lead are equal. So I wouldn't really call this raw. But anyway, it doesn't matter. You can see that this is working, and if I refresh, see the timestamp changes. Sometimes the temperature changes, mostly not, because thermistors, at room temperature, it's yeah, it is chilly in here. So we'll refresh again, and then there's a post. There's an API status, but there's also API post. Let's see, which doesn't show anything in the browser, but it's there. So the PHP script does write to this. It does a post, and that's what changes the LEDs. You can't actually do it from your browser. It requires curl. We're using curl to do that. So we're using curl to read the state, and we're using curl to post the LED command. And what does the LED command do? It turns these LEDs on or off, and every I don't know what I have, 10 seconds, 15 seconds, it updates here. So I don't pound the Pico 2W too hard. I don't make requests every second. I don't make requests every 10 seconds. I keep it at a reasonable pace, and of course, I keep an eye on the database, because the database right now, it's saying 1,489 records. These are temperatures. And let's refresh it and see how many have grown since the last time I queried. Oh yeah, see, about 500 more. So, it's the highest temperature. Whoops, that's lead. It's the highest lead temperature. Yeah, 83 it says. I'm sure it wasn't 83 in here. I could have been breathing on the thermistor, something like that. So, there we have it, and I'm going to explain this in greater detail, including the hardware, in the next video. Thank you for watching.